presenters, ladies and gentlemen, esteemed guests and fellow scholars, it's my pleasure to speak to you today about the fascinating topic of universe geometry and black holes. As we continue to explore the vastness of space, we are constantly amazed by the intricate pattern and structure that exist within the universe. From the intrinsic swirl of galaxies to the mysterious and powerful forces of black holes, the study of universe geometry has opened a new doors for the understanding of the cosmos. So mm, you can see in my PPT here we write the ratio of the universe circumference and diameter equal to the speed of light. So basically it's something like a equation area of the circle like a 2 pi r. So in pi we can consider see in a universe geometry, um, because our universe is look like a sphere but not a proper sphere, because because the in dark space time we will consider universe boundary at the final point of light waves. So by mathematical model we can take the some conclusion which is below. But as galaxies are rotating around the gained black hole of the universe, so light distance will vary from the as rotating around the black hole. So we cannot calculate the circumference and their diameter from the normal equation like a 2 pi or something for pi r square. So there are some equations like a universal circumference lines. So we consider by the circumference line you can say this is also the arc length of the universe by this equation. These equations are not proper here because in a PPT these equations some distorted, but the actual equations are here. Same equations are here. For the universe circumference line, we can calculate the something like a perimeter. You can say. So here is the T1 and T2 at the time. Because our we can say the curve line of the universe ending point are not exact the same as time varies. So here T1 to the time and underscore G1 is the metric tensor or xi are the coordinate system. So we can calculate the universe circumference by these equations, and also we have to calculate the diameter of the universe. So above equations or something generally mathematical diameter equations are not applicable in a universe geometry. So we have some differential equations, and these are the chronicle delta in xi coordinates. So we can calculate the universe diameters by these 1.2 equations. So GIR in these equations, this is a basically equation of a straight line in a differential equation, and we can conclude some or you can predict some properties of the universe by the mathematical model, so which are below here. We can say we are on the edge of the universe, not exactly the edge of the universe but somewhere around. Definitely we can calculate our position like a latitude or longitude coordinates. We can change also our coordinate system to cylindrical or a spherical coordinate system as we want. So and in the next one is all massive object and galaxies have different shape and area with the speeds. Yeah, our planet have also different shape with the speed in while rotating around the sun. So if our planet moving with the very large speed, our earth space shape will definitely change something like a cylindrical or another whatever. You can imagine a simple straight line in a with the speed in a high speed, not a normal speed. And next point is all the shape of the path of the universe planet revolution is not a perfect ellipse. I mean, suppose our planet are rotating around the sun, so basically we can consider our planet path or the elliptical. But in a deep, you can consider our rotation path of our planet are not perfectly. It is something like a deflection with the half quarter of a spiral in path, something like a spiral in a little path of the little section of path of the ellipse. So little type of some deflection in like a spiral. Next one is all space-time curvature is also relativistic. Our solar system moving in a sectional curvature of a space-time. So the space-time curvature is also relativistic because some explosion of the galaxies or some destruction of the galaxies or moving and gaining of the object gaining of galaxy of black hole, so these are the create some deflection in a or also in a space-time curvature. So we can calculate the space-time curvature by these equations. Here you can say k s vector and v vector are the geodesic. Basically space-time curvature geodesic from the numerator we can calculate, and denominator is also the part of the space-time curvature. So if this one is equal to 0, then geodesic is not separated, and this one is equal to positive, then geodesic is converging, and this one is less than 0, then geodesic is diverging, and simply this one is a normalization factor. And next point we can conclude that there is a massive black hole at the center of the universe. It's not visible from the our eye, but we will find definitely in a near future. Uh, the, and the next point is the study of my PPT is that one black hole. So the study of black hole has revolutionized our understanding of the universe, revealing the power of gravity and true nature of space and time. Scientists have used mathematical model and advanced computer simulation to explore the properties of the black hole, including their event horizon, acceleration disk, and jets of the high energy particles. Moreover, black holes can serve as a natural laboratory for the testing the limits of our current theories of physics. By studying the behavior of matter and energy around the black holes, we can test the prediction of general relativity and explore the possibility of new physics beyond the standard model. In conclusion, the study of universe geometry and black holes has opened up a new frontier in our understanding of the cosmos through the use of advanced mathematical model and computer simulation. We can explore the complex structure and forces that shape of the universe around us. And by the studying black hole, we can gain the new insight into the nature of space and time and the fundamental laws of physics that govern our world. So here are some observation for the black holes. Actually, many scientists theory already available or given it is easily available in the googles. So I'm here presenting the actually how black holes are look like, or how it created. So when a star move at the velocity v, you can say this velocity as a cyclopean velocity, and their atmospheric gases are not able to escape anywhere. Then due to centripetal forces and atmospheric pressure, it will form a black hole. So we can write the same situations in a by the mathematical expression. So this equation gives the black hole equation, where pt is the relativity pressure, m is the mass energy tensor, and r is the radius of black hole, kv is the constant, and this is the velocity of near black hole. GIK are the metric tensor. When two galaxies pass, we can also analyze the situation when this situation arises. So when two galaxies passes close to each other, then a star are also very close to each other in a space time. And horizontal alignment of a stars create a gravitational torque mgr. Finally, at the velocity vc, vc, that means cyclopean velocity, will form a black hole in a giant galaxy. For the at the center of the galaxy, due to density of the star, situation well will form. One another situation is also wherever in our universe a large black holes lies. So at a time span, at a large time span, there will be some situation occur like that in a center of the galaxy due to the density of the stars. So same situation will be formed. So we can consider the black hole will be formed or about to form in a Gantt galaxies. So also, and black hole have some spins, something like the Earth has has a spin, and our sun has also a spin. So black hole has also a spin to 0 to 1. We can calculate our spin in a 24 days or in a year. So also black hole has also a spin during the time of, and the next point is during the time of gaining massive massive galaxy or a star, followed path of object will be a spiral. Whenever galaxy gain the stars or a star or the galaxies, there you can say galaxy not something like a treat as an object. We and similarly distract them. If you, actually black hole rotate them in a spiral path, then after it will fully get the galaxies. So the path here we can uh, give some here I'll give you some equations. Here are yeah, this is a basically equation of the spiral, and theta, where theta is the angle of the rotation as a spiral curve, and ri is the radius of each turn, and a and b are the constant that depends on a particular spiral. And next part is the destruction. How black hole will be we can say black hole will be also destruct by manually, but here I'm explaining the situation when black hole will destruct. So uh, here when more than two massive galaxies rotated around the black hole, and during the time of gaining at the BD radius of the black hole, collision of the galaxy will occur in this situation. Black black hole pressure BP, where BP is the black hole pressure and GLB the galaxy pressure due to high speed of revolution, and BD is the position of the spiral radius of the black hole, where black hole pressure less than sum of rotating galaxies pressure. So that's my research on the universe geometry and black hole. You can say my you can say my observation or a research on a universe geometry and black holes. So simply I give the name as a title, universe geometry and property. Thank you for.
My name is Naresh Singh, and the topic of my research is fake news detection using machine learning with two other co-authors, that is Mr. Suraj Rondiar and Ms. Kunya Kardam. So first of all, we see what does fake news refers to. Fake news refers to the fabricated or misleading information in such a way that they are real news. It is often designed to deceive readers or viewers for political, financial, or other purposes of by any organization or by any individual. Fake news can be spread through various mediums: social media, websites, newspaper, or any other media outlets. Fake news often seems to play with people's emotions and biases rather than providing accurate information based on facts and evidence. This is to create confusion, sow discord, and erode trust in institutions, experts, and the media. It is important to be vigilant and critical of the information we consume, and to verify the sources and accuracy of news before sharing it with others. So the consequences of fake news are, first of all, misinformation. The spread of fake news can lead to widespread misinformation, which can cause confusion and misunderstanding about important issues in the market real time. The other is damage to reputation. Fake news can damage to any individual's reputation or any organizational reputation. Which the other one is polarization and division, that we can see the society get polarized towards one person or one towards one way. So it creates division in the society. Harm to public safety, as we have seen in the COVID times, many of the institutions or individuals have spread fake news about the vaccines and all, which have lead harm to the society and individuals' life. So this needs to be stopped. So we have created fake news detection. It is very necessary for many reasons. Firstly, we can see it has serious consequences, such as spreading misinformation. It can cause harm to incite violence. It can increase the violence against government institutions or scientific community. Secondly, we can see fake news can be used to manipulate public opinion during the elections or anything like that. Thirdly, fake news can be used to deceive people for financial gain, such as by spreading false information about the company or product to boost sales. So overall, we can see fake news detection is necessary to protect individuals, society, and democracy from the harmful effects of misinformation. It is important to develop tools and techniques to identify and combat fake news and to educate people on how to critically evaluate the information they encounter. So this is the model workflow we have created using machine learning, how to detect fake news. The workflow for detecting fake news using machine learning can be divided into several steps. The first one is data collection. That is where we collect a large data set of articles or news stories that are labeled as either fake or true. The other is step is data processing, where we clean the cleaning and pre-processing of the collected data, which removing and stemming or lemmatization and converting textual text to numerical representation, such as techniques using TF, IDF, or word encodings. That's come under data vectorization. So now we come to data splitting part. Once the data is vectorized, split the data into testing and training purposes, and then we train a model from the training data and further we predict the accuracy of a model. So data set here we have taken is a well-labeled data set, which means it consists of both true and fake news in a well-labeled manner. It has around 20,000 news articles, which contains real and fake news in a balanced way, as you can see in the image below. It contains title of the news, the author name, the textual data, and labeling that 1 represents for the true news and 0 represents for the fake news for the model training. So classifiers we have used here is logistic regression, naive-Bayes classifier, decision tree, and random forest classifier. We have used various classifiers to check the accuracy of our trained model on various other classifiers. So we can see project flow and data collection. Large data sets of real and fake articles from a variety of news sources are collected and labeled. Data pre-processing of that labeled data is done to fill the null values, balancing of data, tokenization, and stuff. These all come in the data processing part. Now, once the data is pre-processed, we have done data vectorization using TF, IDF vectorizer in our case. And the vector data is then further splitted into ratio 3:1 for the training and testing purpose. The 75% of the total data gets into a training part, and the rest remaining 25% of the data we use for our testing purpose to check the accuracy of our trained model, machine learning model. Once the model is trained, it is evaluated and can be deployed in a production environment. Deployment can be done on any website or any social media app. There are various ways to deploy a machine learning model. We will talk it later. So these are the performance matrices. The model prediction performance metrics in machine learning are used to measure how well a machine learning model is performing on a given task. This matrix helps to determine whether a model is accurately predicting the outcomes for the given data and how well it generalizes to new data. The choice of performance matrix depend on the nature of the problem and the type of model being used. Some commonly we can see here, that is accuracy, the percentage of correct predictions made by the model. Precision, we can see here, precision, the fraction of true positives among the predicted positive examples. Recall is basically the fraction of true positives among the actual positive examples. And F1 score, the harmonic mean of precision and recall, which provides a balanced measure of both the matrices. These metrics are used to evaluate the performance of machine learning model, and they help to determine the effectiveness of the model in solving the problem at hand. By comparing the performance of different models on a given task, researchers and practitioners can determine which model is best suited for the problem. So we have used precision recall and F1 score method, and confusion matrix also is created for each and every ML model. So classification report is here for all the classifiers we have used. That's a linear regression. We have found the highest precision recall and F1 score in a linear regression. And on the second number, we have found random forest is very close to linear regression classifier. And further decision tree and naive Bayes classifier are there. We can see accuracy of all the four classifiers. The linear regression shows have shown highest accuracy at 94.8%, and after that random forest is very close to linear regression, and decision tree and naive Bayes classifier have shows less accuracy as compared to linear regression. So once our model has been trained, we can deploy our model on various from various sources. The one is through web browser extension. We can create a web browser extension for any particular browser, and it can, once it is get activated, it can easily, a web browser can easily detect any fake news present on the social media or any other website. The other means to deploy it is mobile application. We can create a mobile application from where a person can paste any link of any news, and it will easily detect whether the news is fake or true. The third one is social media. As we have seen, social media apps like Twitter, Facebook, they have created their own fake news detection team, which detects the fake news on their particular platforms. So it can be deployed over there also. And thus further on the news websites, people read news on the websites, so we can deploy our model over there also. And it can also be used as email filters, where we can detect whether our email that is coming to us is true or fake by some means of training. So here we conclude that we have found the highest accuracy of linear regression algorithm. So as we have seen, accuracy depends on classifier to classifier. So fake news detection is a very dynamic topic, as every day millions of events occur and number of fake news are spread in the market. In this research, a single model is not enough to detect fake news and achieve high accuracy. Machine learning can be a powerful tool in detecting fake news. It is important to note that no algorithm is foolproof. Therefore, it is crucial to continually improve and refine machine learning algorithms and to use them in conjunction with human judgment to ensure the accuracy of fake news detection. By regular improvement and regular training of in a model, we can enhance the accuracy of a model, and the accuracy of a model can be maintained.
Yes, sir. Okay, so sir, is my screen visible?
Yes.
Sure. Sir, is my screen visible?
Please go ahead.
Okay, thank you, sir. Okay, so myself, Dr. Divya Srivastav, and my topic for today is semantic CBIR and its application. CBIR here stands for content-based image retrieval. Okay. So the contents for my presentation is what is actually a picture is, and then the what is image, and what when we say image retrieval, then what do we mean by image retrieval, Then there are two different types. First is text-based and the second one is content-based. So here in this, we are focusing on content-based image retrieval, that is CBIR. In the queue, the next topic will be like features of CBIR. Broad categories are global features and local features. And then finally, the applications of CBIR. It is in the it is being widely used in medical imaging, general purpose images, in e-commerce. I have given an example of fashion industry in this, and also in social media. Here I have given an example of face recognition. So to start with, what is a picture? A picture is worth 1,000 words. So it is very well said that writing 1,000 words, for example, if I want to describe any scenery in words, I'll be writing a paragraph. Rather, if I click and just post it somewhere, it itself is going to define what it is. So it is very well said that a picture is worth 1,000 words. Now, when we talk about this, so in computer science, computer vision, we have like image. Now, image retrieval is my topic. So what is a retrieval? Retrieval, it is the process of searching or browsing of digital images with respect to any given query image. That information can be in the form of text or in the form of image itself. So whenever it is in the form of text, it is called as TBIR, that is text-based image retrieval. And if it is in the form of some content means if I am uploading the image itself as my query image, then it is called as content-based image retrieval. So text-based image retrieval, it is generally used when the user is not very specific. For example, if I want to search for any sample images for birthday card images or any templates, so I can easily write like templates, birthday card images, because when I am not being very specific. But if I'm being very specific that I want the front face of Amitabh Bachchan, or if I want a front view of any particular thing, or say, for example, here I have given a specific rose which has different colors like red, pink, yellow. So here my search is very specific. So in such cases, content is based image retrieval is more relevant as compared to text based. In the PPT also I've shown one example that if the same thing, if we write some text, for example, if in the here I have given an example of jaguar. So if in the Google images, if I type jaguar, so jaguar, it can take it as an animal, also it can take it as a car. So there is always a semantic gap. That is what my topic is, semantic CBIR. So semantic, always there is a gap because one word can have more than one meaning. For example, if I type orange, so orange can be a color, orange can be a fruit. So while retrieving, your annotation has to be very strong that it only gives the particular result. Whereas if I upload my image, for example, in this, if I want to describe this particular rose, so I, as a person, I can write it as shaded rose, rose with different petal colors, rose with different colors. So if I show you the result, so I got these results. Like if I'm typing shaded rose, I'm getting pencil shaded rose. Rose with different colors, then I'm getting these variety. In the third image, in the third result, somewhere similar result I am getting. So for one particular thing, I am writing so many queries again and again, and then I am getting. But if I direct upload this image as my query image, so visually similar images I am getting. And if you see all the top 10, 15 images are exactly similar, or we can say very much similar to my content-based image. So this is CBIR, that is content. I am uploading or I am using content as the query itself. Okay. So when we talk about content, so content, what is the content of an image? Features. So image can be defined with color, shape, texture. Then we have some descriptors like SURF. SURF stands for speed up robust feature. SIFT, that is scale invariant feature transform. And to represent those features, we use bag of words, histogram, etc. Now, Global features are basically divided into two broad categories. One is global and local features. Whenever we talk about global, so as the word itself refers, global means complete. So whenever if I am not very specific to any particular point in my image, I am taking feature of the complete image, then that is called as global. Generally it is texture, color, or shape. Local feature means if in an image, for example in this butterfly image, I am taking some particular points only, like the where the petals are white, petals are black, petals are red, then I am not taking features of the complete image. I am first identifying some important points, and then I am extracting those features. So for such things we have surf and sift, that is local features in an image. Global features, color feature. Color is most extensively used visual feature, and it is nothing else but the color. It is a 3D values, and it is a tri-component vector, generally shown as color space. So in this figure, we say that it is HSV color space. Three color spaces are there: black, white, and HSV, and the combination is saturated. So whenever we move, if this vector moves in the upward direction, the saturation increases. Now second is shape features. Shape features are very rarely used because these are generally used for those images like when we are working on logos, trademarks, which have particular shape. Then we go for shape features. The most common is texture features. Texture features because texture defines the surface or the tactile characteristics of an image, whether the image is coarse, regular, smooth. So in this example, if you see, I have given some of the artificial texture. Artificial textures are like when there is particular pattern, like in this bricks. So the texture is fixed. Whereas if we see like waves, then at some point of time the waves are high, at some point of time the waves are low. So that is an example of natural texture. So texture features are more commonly used for content-based image retrieval. The different texture feature method are perceptual methods, statistical model, local binary pattern, structural method, transform method, and MPEG7 texture methods. Now, earlier the three features that I have discussed was color, shape, and texture, which are global features. It means when we are taking this, then we are taking it for the complete image. We are not finding out some points and then extracting the image. The next is the global features. Global features, there are two different things. First, I need to identify the important points in my image, and then I'm extracting only those features. So example of local features are sift and surf, which are more commonly used. So if I have taken example of here, surf. It works in three phases. First, it identify the key points in an image, then description of those key points, and then if I am matching, because I want to retrieve something, so the two images should be similar. Then the third phase, it matches the key points, not the whole image, but the key points. So here in this, you can see there are two images. First is synthetic image. Here I have simply drawn a triangle, and since the intensity is changing at each corner, so these are my important points. But in the second image, if you see that it is a natural scene image, so whenever the intensity is changing, so by interest points, it's simply that wherever there is a drastic change in the intensity values. Now, for example, if you see sunflower, brown color is in the center, whereas yellow. So brown and yellow, drastic change in the intensity, so it is an interest point. Similarly, mountains, blue, trees, green, sudden change in the intensity. So these are my interest points in any image. So this is how we decide an interest point in an image. Now in the next, if we go, so here I have taken all the three faces. First, I have identified what are my interest points in my faces, and then I am matching the interest points. So these yellow lines show that, okay, these are the points which are matching in image 1 and image 2. So how much, if the 50% is matching, then we can say the images are somewhat similar. If it is the matching is more than 80%, we can say, okay, if much more similar. If it is 100%, then we say it is an exact matching. So this is how the local feature works. So using these applications, several researchers have used this applications in its applications. For example, applications of CBIR. The first example I have given is in the art collections. So Fine Art Museum of San Francisco. Here it is, because when we talk about art museum or something, so here we need to have an exact match. For example, if you're talking about the painting of Mona Lisa, so it does not mean the similar match is my exact. No, all the points, each and every point should match. So here SURF comes out. Medical image database may, whenever we want to do CT, MRI, ultrasound, these are some of the applications where the content, because the visual, we have X-rays, we have films. So here CBIR plays more important role. Similarly, in some scientific database, example here is Earth Sciences. General year collections like Getty Images, Corbis. Now I have taken 3 examples to clearly explain the image retrieval based on content. So here we see medical image. So if I am uploading an image of a general disease, and then I am searching the results, that if this is, so this sort of X-ray I have, then what can be the possibility of disease. So here comes my similar matches compared to this. The next is, I have taken, like, in from the categories of dog, there are so many categories of dog. So my query image is of a dog with black and white patches. So if we see the results, out of 15, top 15, the last, which I have highlighted at red, is the only one which is quite mismatch. Otherwise, we find that till 14, 15th, first 15th, 14th positions, I am getting the exact match of a dog which is having black and white spots. So this is the benefit of content base. Otherwise, if I'm writing this in query, I have to be very specific, like dog with black and white spots. So rather writing those 10 words, I'm simply uploading an image. Here, I have given an example of content based in the case of fashion industry. For example, we apply a lot of filter like shirt with horizontal stripes, vertical stripes. Then we have braided patterns, then other patterns. So instead of writing it, if we simply have an image with us and we upload it, we can get accordingly, we can get our choices. And the last one is, it is very much used in social media, that is face recognition. It is also used in automatic face recognition. Whenever we are posting, Facebook suggests us, do you want to tag Mr. X? So how does Facebook? Because Facebook has that similar image in its database. So it matches, and if it found some similarity, it suggests us that, do you want to tag this? So this is an application, another application of CBIR, that is content based in face recognition. So this is all about my presentation. Any query?
I'm Dr. Pimtawan Jantan from Social Study Department, Srinagarnavira University, Bangkok, Thailand. My topic is the research of program in online instructional during the COVID-19 pandemic among student teachers in the field of the social study in Faculty of Education of Social Science in Srinagarnavira University. Then, okay, the current research aims to the study problem in the online instructional in terms of the content preparation, instructional plan development, instructional design, instructional media development, classroom management, bonding and self-adaptation, as well as suggest the possible solution to authentic the problem. The symbol include 32 social studies student teacher in the school of the Faculty of Social Study, Faculty of Department, Singapore University. The research study was have a quality student by adopting in-depth interview in obtain data to analyze descriptively. The social results revealed that the student teacher were anxious about the content accurate. The efficiency of instructional management and the upscale is assessment and evaluation in attention student we are deprived of the motivation to the study. One of major solution and ensure good content preparation about to create a positive learning atmosphere. This is an introduction about social study country. We are required to obtain the authentic training in the school. The final academic year accessory, as in class, the teaching into online teaching due to COVID-19 pandemic to worldwide affect all the world. A good instructional preparation is attribute composed by all citizens, include content preparation, instructional plan development, instructional design, instructional media, and development, classroom management, bound to self-adaptation too. My objective, the current situation paper aim to the study program in online instructional the terms of content preparation, instructional plan development, social studies side, design instructional media, and classroom bonding to self-adaptation, as well as we are suggest possible solution that alternative the program. My research have 5 steps of the research procedure. 1, to involve the study, and step 2, selection the symbol. Next, the adoption of the research tools and implement. Finally, we are report to the research result. Step 1, I will involve to study and interaction about theory in the social study theory area, about progressive theory, reconstructionism of education, online teaching, and COVID-19 pandemic. And we are analyzed about theory, have a program in online instructional content preparation, instructional plan development, instructional design, instructional media development, classroom management, and self-adaptation. So, step 2, enter the selections sample. The sample have 22 5-year. 5-year is finally of our student. Our social studies student in Singapore University. The finally years, the student will be going to prepare the social study teacher in the school. My faculty who are receiving authentic training the first semester, there are 2 data collection to face. Phase 1. First, of which during the vocation training, in which data collection the middle of the academic years, while they attend the training into other family students with the school policy and instructional management, the better themselves to online teaching. The instructional management was composed of 5 terms, include citizenship, cultural and lifestyle, economics, geography, moral, and historical and religions. For primary school, my student must to teach about primary school and secondary school of Thailand. The second phase took the place after the vocation, training, and join. And the student teacher has experience in the all aspects of instructional preparation, including instructional management, assessment, and evaluation, and other aspects such as consultation, responsible to students as supervisor and participate in school activities. The data will be collected and in-depth interview and analyze. Step 3, we want adoption to research 2. We have two sections. Section 1, relation about program online instructional management, content to preparation about anything, development, instructional design, instructional media development, classroom management, bonding, and self-adaptation. And section 2, we approach to develop effective online instructional for social study, religions, and culture. The researcher conduct 2 in-depth interview. We are the middle vocation training about and IOC involved, its equation, evaluation, and everything. Step 4, the conclusion, we was concerned the research implement. The research tool was used to the interview the simple concerning content preparation, instructional plan, development, instructional design, instructional media development, classroom management, bonding, and self-adaptation, solution, and along the solution, the program. And finally, report the result. Conclusion, the research results reveal the student teacher were nervous about accuracy. The subject content will belong to first. The first student covered a wide scope and 5 terms, which are geography, history, religion, citizenship, and economy, of which demand genetic amounts, preparation time, as well as up to date information. The student teacher asked us about the content accuracy, the effective of instructional management, and obstacle as in assessment or evaluation. In addition, students were deprived of the motivation to study. One of major solutions we to ensure about good content preparation and create positive learning atmosphere. This is picture when my student teach online in primary school and secondary school. This is sociology. This is food. This is traditional of Thailand and culture. Maybe. Okay, thank you for your attention.
Thank you.